All right, welcome everyone. This is our weekly build meeting session. We will have some questions at the end, but if you can put them in the chat, or if it's really important, just raise your hand. We'll get to it. My name is Andy Lynch. I'm one of the volunteer mentors, and what we're going to go over is a quick slide overview. Hopefully everyone can see that. And then I think what I'll do is I'll just use slideshow. Yeah, that would be better. So for those that don't know, we have multiple schools going on with every week here. So multiple schools from Houston ISD. We had a good meeting at Lamar yesterday. Typically Lamar will be our main Saturday meetings. We had some good turnout from Carnegie, from Westside. So we got all three schools getting pretty active, which is great. DeBakey is another school that we work with, but they're typically just doing VEX at this point. And let's see here. So programming wise, we did some good work on the robot, doing some April tags, and I think they were able to get some of the pose estimation working. So I think that code is going to be checked in, which is pretty important on how you can get your position on the field. So they're working through that. Drew is also looking at path planner stuff, and I'm sure we'll have more updates on that. It's just not quite tested yet. But if you want to program, we want to just encourage everyone to get into programming, because you just have to set up your computer. You have to have some Java knowledge, and we can put you to work. There's lots of things to do. Programming is going to be really important this year. Same with CAD. If you have some CAD skills and you're just not that familiar, we can find something for you to do. Cedric is in charge of CAD. He'll give a big presentation about it. Levi's been doing a lot of work on Shooter, and a lot of people from Westside have been working on intake. So we have lots of different mechanisms that we need to work on. We've been talking about getting like a space allocation, and Cedric's going to walk through that. But we really need to box out the mechanisms, like let's say a climber, and we're going to say the climber team has this much space to work with. Here's kind of the basics. Let's start the careful analysis to make sure everything's going to look right before we start cutting parts. We have done some assembly. We've cut some drivetrain rails, and we're putting together the belly pan. We actually CNC'd the belly pan out of polycarb on Saturday, which is pretty exciting. And we're just slowly working through it. So it's a good step. Just so everyone knows, all the schools are having meetings, and just check in with the different school leaders about what's going on, how you can contribute. You can meet right after school at Lamar, Westside, or Carnegie. And then we do this every Sunday online. So that's it for me. I'm going to hand it over to Drew if he wants to share, and I'll let him present what he's working on.
Yeah, so let me see if I can share my screen. Let's see. No. Okay. If y'all can you guys see my screen?
Not yet.
Oh.
Hit the share button on the, it's like a computer monitor.
Yeah,
a happy face.
I'm not sure if,
It might bring up a window and say, what screen do you want to share?
Can you guys see it now?
Not yet.
Oh, that's it.
If you want, Drew, if you want me to just share my screen on the Onshape, I can share it and you can explain everything that you.
Yeah, I think that would be better, because I was trying earlier and it wasn't working.
Is it just the main assembly, or do you want the climber talk?
Just the main. I guess main assembly is fine. Yeah. So, okay. So over here, basically what I've done is that with Cedric's, like this kind of works with Cedric's climber as well. And actually, I don't know where his climber went.
Oh, I hit it. It's right
there. Yeah. So this works with Cedric's Climber because Cedric's Climber is quite simple. So it would use just these two latches that are spring loaded, and it does need some spacing and working because it interferes with Cedric's mechanism right now. But if we get that spaced out, this can like make us do a level 3 climb, because we would have these like orange, I don't know, hooks. They're spring loaded at the back, and they can only go down. And that way, when Cedric's Climber goes to the next rung, these things hooks on, and then the climber goes to the next rung until level 3. And if we can get spacing worked out, and then also move the limit of Cedric's Climber lower so that the bottommost point is lower than the hooks itself, then I think it could like serve as a really good tier 3 climber. And another thing is that, like, another idea is that if this doesn't work itself, we could also use the Andy Mark. And I was doing calculations, and using the Andy Mark's climber in the box itself, you would have to cut around, I think, 20 inches from each of the elevator tubes. And that would allow it so that if you have two simple hooks, it would be easy to just latch on from the front of the tower, not from the side like how this one is right now. It would attach from the front of the tower, then you'd have two simple hooks, very similar to the ones over here, but facing towards the front of the bot. So these are like kind of the two designs. And I know recently Misha also sent a video that was kind of like a double elevator. So the hooks were at the side of an elevator, kind of like a Cedric's, and you would hook to the tower from the front, and the hooks would move along with the climber. So these are just a couple ideas, but I think this one's quite simple in itself, but I do just have to get the spacing right between the hooks and Cedric's climber.
Great. Yeah, it sounds like we have a lot of details, but the main goal is to build a level 1 climber, which I think is mostly what's shown in this CAD. And we're going to test that. And then the level 3 is kind of an upgrade, but we should be careful about spending a lot of time trying to integrate around a level 3. So just be aware how much space you have, Drew, and that's pretty much all the space you're going to get to execute it. So
yeah.
Levi, you want to go next?
Sure. Let me share my screen. There we go. Where is it? Oh, here it goes. Okay. So I've been working on the shooter. So I was thinking of having it in the back, but I talked with Cedric, and that doesn't seem like it's going to work with the Spindexer. So I've moved it to the side here, to where it can shoot out basically opposite of the climber. Cedric originally had it shooting out away from the intake. I think that this would be a little easier to package because it's a little shorter this way than it is this way. And it's also a little easier for the ball to go in here than it is for the ball to go into the side of the indexer. So the actual shooter, basically the way it works is you have your opening here, and the ball comes in, and it's basically pushed by the Spindexer, and it'll hit these wheels. And these go all the way up to hit the flywheel, so the ball will go up here, and then it'll hit the hood. And it's an adjustable hood, so we can adjust this independent of these, and it can shoot out at this angle, or we can move it, say, up like this if we're shooting really far to a certain point, and we still have backing here, and the compression is always under like 5.5, so you're getting good compression all the way through. So like a lot of this we can just prototype by doing polycarb, and then we can just like use the Lexan piece here that is zip tied to the two side plates here. So, and then this back part can be 3D printed, so it's a little sturdier than just plain Lexan. So that's what I've been working on. I think it's a little better than what I had previously. Cedric also mentioned, what was it? Rembrandt's washing machine, which it looked like they had a spindexer in the center and the ball came out from the middle of the spindexer. I think that also might be interesting because we could then basically take this shooter and move it to the center, and then now you no longer have this space taken up by the shooter, and that can be used for battery or electronics or more hopper space. So that's also something we can think about. So yeah, I think that's everything.
Great. Cedric, you're up next.
Okay, so I think the biggest thing that we kind of decided on. Oh wait, hang on, wrong screen. There we go. A big thing that we decided on yesterday was me and Carl sat down and really looked at climber concept and see what we could do. That those discussions carried over in today, and what we landed on yesterday was we knew we wanted to kind of just use the climber in a box just because it's very common by now. It's been tested for many years and many teams have found great success with it, even when putting it at an angle like this. So by using them, we wouldn't really need to be engineering a whole brand new subsystem like we would an elevator, like we did last year. We really like the main system is there. We just need to figure out the geometry and some of the bracing, which would be a lot more feasible than a whole subsystem. And what we landed on was that we wanted to basically climb on the sides of the rung, the part that's sticking out of the upright. This is mainly because we realized that a level 3 may not be within our team scope, and a bunch of the level 3 climbers will probably want to go somewhere in the center. So us being a level 1, I think we would be a better alliance partner if we climbed on the side where we took up less space. And so the higher climbers who can get us those points, they can go in the middle and take whatever space they need to climb. We decided that we wanted to do this angled, mainly because we noticed that with the way our bumpers are set, we actually do the actual rung actually doesn't protrude into our frame perimeter nearly as much as we initially thought. So in order to get more of the rung, to get more of the rung on our robot to be more safe, we have to put this at an angle. The other alternative solution was we would have to make something that deploys in and out, and we thought that was just too much. That was too complex, and because if we wanted to do this in auto, we would need to do it. We need to have it extend and then retract, and that's just more stuff that I really don't think we should worry about. The way this climber in a box setup works, let's isolate. This would all be powered by one motor. So it'd have one motor here on this end, and then a shaft that goes all the way through both pulleys. So it's all the motion is synchronized and will always be level, which is a plus compared to 2 motors. The nice thing here is that we also found a geometry where the battery can be pretty snug in between. I think we would still need some sort of additional plate and probably straps just to make sure the battery's secure. But yeah, we were able to fit the battery here, which we agreed we liked because of it's closer to the CG of our robot. And then in terms of mounting this at this angle, you can see I have some of the tubes set up here, but we discussed this idea with Carl. We would basically just CNC a custom plate here that connects the tubes and the bottom of the climber in a box to brace it, and then we would have an additional see if I can find a picture of it. An additional, the purple would be a steel cable to add some additional support to our system, because we think, because this has to hold up the weight of our robot. So we need to make sure it's pretty robust and pretty strong. Other than that, I think we really just need to kind of just start really figuring out, like, okay, what do we want to do? What do we want to prioritize? Because I think that kind of stuff isn't fully clear yet. And it's getting, I mean, it's only week 2, but at the same time, I just don't want to have to rush figuring out the how of each and every single mechanism. Like, I would rather start that process as soon as we can. So I think our priorities for CAD is going to be just really just figuring out what we want to do, seeing really which is best. Like, for example, this intake, we're still really unsure about it because we just haven't had the chance to test it in its full setup. I know Devansh has been working on copying the WCP intake, which is just a slap down intake that uses the silicone rollers. So we have to really, we really just have to decide, like, what do we want to do? Because the sooner we can do that, the sooner we can really refine out the details of the how of each mechanism. And I think that's going to be more important this year than it was last year. And so I want to maximize how much time I have, and just maximize how much time that we have to really dial down these mechanisms and then find the issues sooner and fix them sooner and really optimize them to get ready for competition. So yeah, I think that's our main issue right now, is just we lack a strong direction. You're muted, Andy.
Yeah, I think it's also good for us just to separate who's in charge of these mechanisms. So right now, Levi has been doing a lot with the shooter, and that's been working with the people at Lamar. And Westside has been working on the intake. The climber hasn't really, I mean, we're still kind of in very early stages, but it needs to be actually prototyped and built out. So don't feel shy if you want to work on a certain system. This is a good time for us to start talking about who's going to be on what system, but each one of those systems needs to be just really focused on testing their mechanism and making sure it fits. And then Cedric's just going to control all the mechanisms together in the entire master CAD of the robot. So there's no conflicts and nothing's going to, have a space issue.